You guys are 12th graders, or 9th and 12th graders, so you're high school, okay?
Okay.
After the screen still. Lights on the
Should I not turn it off?
Actually,
Should I just leave it
we'll
on?
see.
Still good? Yeah. Students! Good afternoon. Does that work? Perfect. Can everyone see? Can everyone see their hands in front of them?
Yes.
Yeah.
Yes.
Can everyone tell me what this is? What is that?
Space.
This is a place we never go.
Yes. We never go. And today I want to ask you one question.
I never say we never been.
Where did we come from? Hey, high schoolers aren't like third graders.
Pretty model.
Well, okay, take religion out of this. Remember, this is a public American school. You know, we're all not just
Alright.
Mormons.
From my
But,
mommy's tummy.
okay, that's an answer. Let me ask you this: Where did humans come from? Where did the world come from? Where was there a start? Think about that.
From monkeys.
From monkeys.
From monkeys, according to evolutionary theory. Okay, but today we're going to talk about not just humans. We're going to talk about the universe. The sun you see, the light you see, the stars, everything had a beginning. Yeah, or maybe not. Well, today we will be learning. Okay. Think about those questions I just asked you. A couple of you are going to share. Okay, so take 1 minute and think about these questions. I'm going to pick on a couple of you. Think.
Well, what question was that?
Where did we come from? Any of you have an answer?
Yeah. Come from monkey building.
Okay. All right, let's have Catherine please answer. What do you think? Where did the universe come from? Where are we all from? Share, please. Take 30 seconds.
I don't know. We just were here.
Good answer. Yes.
We come from a big bang. Poof.
Oh, that's a good one.
And that's where everything started.
Really?
Yes.
Maybe if you put like a big atomic bomb, you're gonna create world.
Okay.
Yeah, but it has to be big, yeah?
Big Bang. So today, we're going to analyze theories of the origins of the universe. Okay? So there's more than one. Big Bang is just one of them. We can't prove that it's right or wrong. It's just what logic, what we know so far has told us. But what instruments do we use to view the universe? Okay, go. Tell us go. I'm just gonna write tell us. Okay, what else?
You know the rest of the word?
Telescope.
C-O-E.
Telescope.
Okay.
What else? What else? Huh? What else do we use?
How
Yeah.
do you call the big thing and go into the
Oh, rocket.
Okay.
Ah, yeah, that one.
Okay, rockets.
Satellites.
Satellites, we use the Hubble Space Telescope. It's just one satellite. That's its whole dedication is towards viewing the universe. Okay, we're gonna look at that in a second. But these are the only two we have
Google Earth.
to view the universe. And as we go through this lesson, I'm going to show you a video right now. It's pretty, for lack of a better term, it's quite dope. It's quite cool. I hope the sound's going to work on this.
They aren't stopping until November. Why should we?
You're stuck with two choices, Hillary Clinton and Donald Trump, or to put that in yoga terms, vanilla and sriracha baboon eggs.
Nearly goes back. I
I heard that Hillary's VP pick was a white dude. What?
Thank you.
When the Hubble Space Telescope was launched from the Space Shuttle Discovery in 1990, NASA called it the greatest advance in astronomy since Galileo. Instead, within days, it became a laughingstock. Hubble had an 8-foot diameter mirror, but a chip of paint on a measuring rod caused the mirror to be 4/millionths of an inch too flat, leaving the telescope with blurry vision. Hubble needed glasses. 3 years later, the crew of the Space Shuttle Endeavour rode to the rescue. Spacewalking astronauts installed tiny mirrors to correct Hubble's vision. The universe snapped into focus. Hubble scanned the heavens with unmatched clarity.
That's a famous galaxy right
Its
there.
cosmic postcards captivated the world. 4 internal flywheels can spin Hubble in any direction. Once pointed, sensors lock on to guide stars, holding the telescope's suite of instruments steady for hours or days at a time. Hubble's cameras record in black and white through filters that isolate different wavelengths of light. Then each image is assigned a color that makes sense to the
Check
eye.
this out, class. This is sick. Ready? This is
When merged,
cool.
this blended light shows the pillars of creation,
Dang.
a dusty birthplace of stars deep within the Eagle Nebula. Just below Orion's belt, the cold clouds of gas that form the Horsehead Nebula are shadowed and opaque in visible light. But Hubble can photograph the unseeable, peering deep into the ultraviolet and infrared, revealing internal structures and the hidden light of newborn stars. Hubble was reborn again and again over the years by astronauts who replaced instruments when they wore out. But NASA declared an end to the servicing missions in 2004 after the loss of the Space Shuttle Columbia. There was a national outcry. In the end, NASA agreed to one last service mission, led by astronomer and astronaut John Grunsfeld. As the shuttle Atlantis prepared to pull away, he said goodbye to the old telescope.
Bye-bye.
After 25 years, Hubble is still surprising us, and its greatest discoveries might still be ahead of it.
All right, friends. What do you think? Hubble Space Telescope. Were those images pretty cool?
Yes.
Yes.
What'd you like about it?
Colors.
Colors. The colors.
The colors, the actually when we look into space, we don't see all that, right? With our own eyes. We can't see all that.
I see it.
X-ray vision. But because of telescopes, we have theories like the Big Bang, and we're gonna play with balloons now, and I'm gonna show you how the Big Bang theory works. So everyone grab a balloon.
I'm okay.
All right.
Sorry.
Step 1.
Oh, you want us to
Draw 3 stars anywhere on the balloon. Don't blow it up just yet. Please, third grade. Detention office. Just kidding. Draw 3 stars on there. Don't poke a hole in it or else the balloon won't inflate, huh? Step 2. Can I have Spencer please read step 2 for me?
Blow 2 breaths into balloon.
Alright, everyone go. 2 breaths.
Can it be a big one?
Sure. Step 3. Pretend you have rulers. Measure star distance on the balloon. Pretend you have. Write it down on your notes. Write it down on your notes. Oh, I only have 10 minutes left. Or 5 minutes. Alright.
2.
Measuring distance, yeah. 2. And you can keep these balloons. Take it home.
Yay.
Step 4. Catherine, please read for me.
Repeat, set, 2, and 3.
Alright, so blow 2 more breaths in, and then measure them again.
Can I type?
Just write it down, whatever. You don't even have to do it if you don't want.
2 more.
Yeah, sure. Dang! Dude, it's gonna explode. You have a lot of air in your lungs. Your balloon should look like this after 4 breaths in total. Yeah, let me see your balloons. Oh, so pretty.
Do we tie them?
Yeah, sure. I know. We're gonna give it to Dr. Shoot after. The principal. What are your results? What are your results?
Oh,
First 2 breaths.
they were closer.
Uh-huh.
Now they're super far from each other.
So are all 3, are some of them closer after you blew the 2 breaths and then it's further
Yeah.
from one
Yeah.
star?
Yeah.
No. I tricked you guys. No.
Yes.
No, they're all further away from each other. Look at your measurements.
Look. See? Look.
Oh, dang. They're all further away, right?
Yeah.
Yes.
Disagree, nod. This is a dictatorship. You're supposed to just nod.
Just because you're the teacher, yes.
So, this represents the Big Bang Theory. As the universe is expanding, everything is getting further and further away. Even the closest galaxy to us, we're getting it further away from it. And it's moving at a faster and faster rate. Ready? Basements, we're going to watch this awesome video.
So who's blowing?
Yeah, who's blowing?
Who's blowing? I think it's God. God's blowing.
But no.
Maybe it's not. Maybe it's dark matter.
At the dawn of time, the universe explodes into existence. From absolutely nothing into everything. But everything is actually a single point, infinitely small, unimaginably hot, a super dense speck of pure energy.
The Big Bang was so immense that it brought into existence all of the mass and all of the energy contained in all of the 400 billion galaxies we see in our universe in a region smaller than the size of a single atom. The entire observable universe was a millionth of a billionth of a centimeter across at that time. Everything was compressed into an incredibly hot, dense region.
Whoa.
It's not even matter yet, just a point of raging energy. It was the beginning of the universe and everything in it.
Everything was simple. All the forces that we know about today were one and the same. The universe was amorphous. It had no structure.
In that instant of creation, all the laws of physics, the very forces that engineer our universe, began to take shape. The first force to emerge was gravity. The fate of the universe, its size, structure, and everything in it, was decided in that moment.
Whoa. What do you guys think? Any questions? I want you to take your balloons and rip a little hole. Don't pop it. Rip a little hole. Rip a little hole.
we're giving it to Dr. Shoot.
And let, oh yeah, we can, huh? Rip a little hole and then push it all back into one little piece. Can you do it without popping it? Let's watch this balloon.
Oh, just one?
Yeah, sure. You guys can give the Dr. Shoe later if you want. So as it shrinks down, oops. What's up with this? Huh? This is messing up or something. Alright. So as the universe is shrinking down, I'll explain to you what happens. So can I take this real fast, Spencer? Can I take yours? Alright, so what happens was in the beginning of the universe, all of our stars, our planet, the whole everything was all compressed into one. Where's that hole at? Right here. That's the smallest little hole. Good job. Make it bigger, speed it up. And what happens is when we look out from the telescope, we see everything getting further and further away. All the galaxy, all the stars. And you know what scientists thought? They thought, hey, if everything's going further and further away, what if we reverse time, go back in time? That means everything comes closer and closer, just like these stars in the balloon. And everything collapses into one point eventually, right? Because everything's moving further away than where it came from was that single point in the video, right? So everything was compressed into this teeny little thing. So this whole Earth, imagine it compressed smaller than a point on a needle. Can you imagine that? Everything. And then take the sun and add everything in the universe, compress it to a single point. So scientists are thinking, there must have been a start to the universe. You know? What do you guys think? Here's some proof that the universe, Big Bang Theory, is right. Universe expanding. So that means if you go back in time, the universe is going to collapse into one point. Okay? A background of microwave radiation fills the entire universe. So when you look out with the Hubble Space Telescope, you see these streams of energy going out. And those are leftover parts from the Big Bang, because they're just energy from random places. They don't know where it's from. So there's some proof to it. And right here, here's some disproof to the Big Bang Theory. Kathy, can I have you read this one, please?
What was before the Big Bang? If there was not time, how can one thing lead to the next?
Yeah, so before the Big Bang, there's nothing. Just imagine nothing. Even time didn't exist according to math. So if there's no time, here's a problem with the Big Bang. Right before the Big Bang, what happened? Where did the Big Bang come from? Did it just come out of nothingness? So that's why a lot of people say Big Bang Theory is actually wrong. Because once you collapse everything into one point, what happened right before that? No one knows. You can't tell. And Spencer, can I have you read this part, please?
Yes. The universe may have existed forever, according to a new model that applies quantum correction terms to complement Einstein's theory of general relativity. The model may also account for dark matter and dark energy, resolving multiple problems at once.
Thank you. So we'll talk about all this in another class, but there's new findings, dark matter, dark energy, all these things are saying Big Bang Theory is wrong. But the Big Bang is the most accepted theory right now in the scientific field. So we are going to look at some alternatives. Alright, and I want you to find a partner. Everyone look for a partner. We're going to do a short activity. Okay. Here is your guys's. Here's you guys do. So you're going to look at your theory. You're going to share one proof and you're going to share one disproof about your theory. These are alternative theories. What is yours, Spencer?
The steady state theory.
Yes, and what is your theory?
Eternal inflation theory.
These are all theories of where the universe came from. Here's the eternal inflation theory, and here's the steady state theory, if you can even see it. So take 2 minutes, circle a strength and circle a weakness, and we're going to present. You guys are going to present to me in a second. Okay, ready, go. No one's talking. So what do you think? What is your theory? What do you guys think? I'm pulling a Dr. Shoe right here. Just like walking around. Hey,
Steady state theory?
what is it in your own words? Huh? Explain to me.
Basically what it is, the universe is always expanding, but it maintains an average density. So as it gets bigger, the mass is either created or destroyed, just that old stars sometimes become unobservable.
Yes, so right here, this is normal Big Bang theory. As everything expands, everything gets further away. But your steady state theory is saying as everything expands, it's still the same density. There's infinite that keeps coming. So circle that part, that's one strength, and then now you need to find a weakness. I'm gonna go around to the other side. I'm gonna test you guys. Is this all pretty confusing? Do you understand this?
Yeah. What's inflating?
Oh, inflate means get bigger, like your balloon.
Oh.
You're not third grader, bro. Okay, so let's see. What do you think? What does your theory mean in your own words? To make it really, really simple, what do you think?
It's still growing.
Just like it says, internal inflation. It just never ends. It keeps growing and growing and
And
big.
it doesn't stop.
Mm-hmm. Okay. It doesn't stop. So that is saying, what is it? Interinflation means it would blow up if such a process. Okay. Here's the weakness. Here, that's it.
Yeah.
So you're gonna share that. But you want to tell the class that there was the eternal inflation means there was no start. There was no start.
It always happens.
It was always here. Okay.
Always.
Mathematically, it can be proved, but here's the weakness. Okay.
Okay.
All right, class, you ready? Ready to present?
So ready.
So I'm gonna sit right here. You guys can rock, paper, scissors. See who's gonna go up and present first. One strength, one weakness. Right. Cohesion group.
No,
Oh, you guys won?
I mean, he was.
So he goes first.
Yeah, we love to go first. Okay, so our theory is eternal inflation. So, in this theory, it means that there was universe where, like they just keep growing and growing, but there's no proof of when that happened. It was always there. So there's no end as well. So which means the creation of universe keeps happening now, even as we talk right now.
Good. Yeah. Now what's one weakness?
All right, one weakness.
When we're in weakness, it will never grow up.
Just read it, see if it makes sense.
Yeah, eternal inflation cannot be stochastic. That
What does
is
stochastic mean?
It was tick.
It means randomize things. So like if you put a whole pieces of a car in a box and you shake it, it won't become a car, right?
Yeah.
So it's saying that this theory doesn't work. Yes.
This theory doesn't work because when something happens, it needs to have a beginning. So something needs to attract one another, for something to happen. It's like when you fall in love with someone, you don't just fall in love like this. Both of you feel something and you get attracted to each other.
Perfect. Just like the universe.
Exactly. And you create someone.
Good job. Oh, I have like 2
That's
minutes.
the beginning.
I'm already past my time. What did you guys get? One strength, one weakness.
Basically, steady state theory says that there's a constant average density in the universe. Matter is continuously, matter is neither created nor destroyed, but some old stars or galaxies become unobservable because of the increasing distance and velocity of recession.
Good job.
And a weakness, because of observations in the 1950s, most notably those of the cosmic microwave background, have produced much evidence contradictory to the steady state theory.
What do you think, Catherine? Fun. Very elaborate. Very elaborate. Good job. So class, now you tell me. You're gonna prove, disprove where we came from. You analyze the theories. You tell me, where did we come from? What do you think? You can say anything you want. You can say you believe in God. You can say we came from Big Bang. What'd you say?
Believe in God.
Okay, there's one answer. You know, science can't prove or disprove that. What do you guys think? Any more comments? Where do we come from?
I believe that someone blew the balloon.
God made the Big Bang happen.
Big Bang must be one thing, but I think Big Bang is good, but somebody must have started it.
Someone must have started it.
That's what we see. We just see the results, but we came after it happened. So we can only observe the results.
Laws of physics are we cannot create or destroy energy. We can't create or destroy light.
But what if we could create it?
Wow, then I think the universe would explode.
No, actually, you would understand where the Big Bang
Hmm. Good point. Alright, students, that's it. Let's all go home. Good class, guys. Good
Thank you.
class.
Yay!
Bye. Now you're gonna give your things to Dr. Shoot, right? Give us a good grade, huh?